Hi class, this is lesson 5.4a, solving compound inequalities. The objective for today is to be able to solve a compound inequality. So first, let's review how to solve a linear inequality. The first thing you want to do for this problem is distribute the 2. 2 times x is 2x. 2 times negative 5 is negative 10. Next, you want to combine like terms. When you combine like terms, you want to look to the left-hand side of the inequality sign and see if there's anything you can combine. I see negative 10 and 3, those are like terms, I can combine those. 2x minus 7. Negative 10 plus 3 is negative 7. Bring down your inequality sign, bring down your 23. Next, you want to start moving stuff away from the variable. You want to get x by itself, so first we need to address this negative 7. We need to add 7 to both sides to undo the subtraction. Negative 7 plus 7 is 0, 23 plus 7 is 30. Last but not least, to get x by itself, I need to divide by 2. 2 divided by 2 is 1, 30 divided by 2 is 15. X is not equal to 15. Remember when we solve linear inequalities, there's multiple values that can satisfy our inequality. Instead of just having one solution, we have a solution set. So we must graph our solution on a number line to represent all of the possible solutions that will satisfy the inequality. So I'm going to start by graphing a number line and putting 15 on the number line. I have a not equal to sign as my inequality sign, so I need to use an open circle. That just means that the value is not included in the solution set. And then anything that's not equal to 15 will be our solution. So I'm going to shade to the left and to the right of that 15. So anything in that green shaded region represents a solution to this inequality. Remember, we always want to check to make sure our answer makes sense and that we didn't go wrong anywhere. So I'm going to pick a value in that green shaded region. I'm going to pick 14. 14 would be in the green shaded region. And I'm going to replace x with 14. 14 minus 5 is 9. 2 times 9 is 18. 18 plus 3 is 21. Well, 21 definitely does not equal 23, so that is a true statement, and therefore that is the correct answer. Had that been something like 23 does not equal 23, well, that would have been a false statement, and I would have known I did something wrong in the problem. When must we flip the inequality sign when solving a linear inequality? Well, anytime we multiply or divide by a negative number, we have to flip the inequality sign. It's okay if we solve the inequality and we get a negative number for our answer. That does not justify us flipping the inequality sign. But if we multiply or divide by a negative while we're solving, that is what causes us to have to flip the inequality sign. So let's talk about compound inequalities. There are 2 types of compound inequalities that we will talk about. The first being an intersection. Linear inequality separated by the word and, or written in the form a number, inequality sign, x, inequality sign, and a number. That is usually the format of your intersections. They will be set up similar to that. You'll have numbers on this side and a variable in the center. That is how you'll know you're working with an intersection. So just like linear inequalities that we talked about yesterday, compound inequalities need to be graphed as well. When we graph these, an intersection is formed. You will now have, instead of just one value for your inequality, such as x does not equal 15, you'll have 2 values that you'll need to graph. Maybe something like x is less than 1 and x is greater than 10. You will need to graph both of those on a number line. You'll follow the same rules as you followed yesterday as far as your open and closed circles and your shading rules go. However, when we talk about an intersection, only the shading that overlaps will be your solution, nothing else. So that is very important to remember about your intersections. When we talk about unions, you're going to see the word or being used. When we graph these, any compound inequalities, a union will form. Anything that is shaded on that number line is your solution. You do not have to worry about anything overlapping. So when we go to check our answers, once again, we're going to have two values, two statements that come about. For an intersection to be true, both statements must be true. Remember, with an intersection, we use the word and. We associate the word and with an intersection. So it would be very similar to me saying something like, Johnny is in biology and algebra 1. If Johnny is not in biology, then that is not a true statement. For it to be a true statement, Johnny has to be enrolled in both algebra 1 and biology at the same time for that statement to be true. The same thing applies in math. If you have an inequality that is true and another inequality that's true, that would be a compound inequality. That's a true statement. It's an intersection. We're good to go. For a union to be true, only one of the inequalities need to be true. So when you plug in and you simplify down, you're going to have two statements, two inequality statements. For your entire compound inequality to be true, only one of those statements need to be true. It's going to be similar to saying something like, Johnny is enrolled in biology or algebra 1. If Johnny is enrolled in algebra 1, but he's not enrolled in biology, that's still a true statement because he is enrolled in at least one of them. So for a union, it's the same logic. When you have those two statements, as long as one of them is a true statement, your union is true, and you know you've done the right work. So as I've kind of mentioned earlier, solving compound inequalities are going to be very similar to what you did yesterday. Only difference is that now you're going to have two values to graph. When we graph, you're going to use the same circle and shading rules as we did yesterday. If you see an open circle, if you see a less than or greater than symbol, use an open circle. If your inequality has an equal sign on it, use a closed circle. If you have a less than or equal to symbol, you're going to shade left. If you see a greater than symbol or a greater than or equal to symbol, you're going to shade right. So let's try our first example. This is what a compound inequality will look like. Notice it's just an inequality separated with the word or followed by another inequality. So when you go to solve this, you're essentially just solving two separate linear inequalities. However, that word or does have meaning and we can't forget about it. So before you start solving one of these, it's important for you to recognize if this is going to be a union or an intersection. Well, I see the word or, so I know it's going to be a union. Always have that in the back of your head when you're solving, when you go to graph, and when you go to check your solution. So the first thing I'm going to do is just write my two inequalities separated, because I'm going to solve two separate linear inequalities. That's all I'm doing here. So on my first inequality, I'm going to solve for my variable. So the first thing I need to do is get rid of this minus 3 by adding 3. On this inequality over here, I need to solve for x, so the first thing I need to move is this plus 5. So to move it, I need to subtract 5. So now I'm going to simplify down. Negative 3 plus 3 is just 0. 9 plus 3 is 12. 5 plus negative 5 is 0. 7 minus 5 is 2. So now I still need to get x by itself, so I'm going to divide by 2. 12 divided by 2 gives me 6. Over here, I'm going to need to get x by itself. Notice there's a negative on there. Don't drop that negative off and call it done. You need to make sure you remove the negative by dividing by negative 1. So as I said earlier, 12 divided by 2 is going to give me x is greater than 6. On this inequality over here, I divided by a negative, so I have to flip my sign. So it'll be x is greater than negative 2. Now you need to graph your solution. So you're going to start by drawing a number line just like you did yesterday and plotting your points. Make sure you put your points in numerical order. Negative 2 is smaller than 6, so it should be on the left. Next, we need to talk about our circles. Well, both inequalities do not have an equal sign. So I'm going to use an open circle on both negative 2 and 6. X is greater than 6, so I'm going to shade to the right for 6. X is greater than negative 2, so I'm shading to the right for negative 2 as well. Remember, this is a union, so anything that is shaded on that number line is your solution. So to check my answer to make sure I've done this problem correctly, I'm going to pick something in that green shaded region. I will pick 0. You could pick -1, you could pick 7, you could pick 9. As long as it's in that green shaded region, you're fine. And now I'm going to substitute 0 in for x. So I had an x here and an x here, and I'm plugging in 0 for that x. Simplifying down, I'm going to get -3 greater than 9 or 5 less than 7. Now remember, we're talking about a union. So for a union to be true, only one of these above statements needs to be true. As long as one of those is true, my entire inequality is true. So my first statement is -3 is greater than 9. Well, that's not true. My second statement is 5 is less than 7. That is a true statement. So I know that my compound inequality is true. That is the correct answer. Next example. This is what an intersection will look like. Notice there is no and, it's just an inequality that has been condensed and compounded. So when we solve these, we're going to draw our attention to the middle, the stuff in between the inequality signs. That's where your variable is going to fall. So you want to start trying to move stuff away from the variable. So the first thing I'm going to do is move over this 3. When I go to solve, I have to start by undoing addition, subtraction. I see addition, so I'm going to start by subtracting 3. Now the only difference is what we do to the middle, we have to do to the left, and we also have to do to the right. So notice I'll subtract 3 in the middle and to the left and to the right. 3 minus 3 is 0. -12 minus 3 is -15. And 9 minus 3 is 6. Next, I need to draw my attention back to the middle. I need to get x by itself, so I'm going to divide by -3. It's -3 times x. To undo the multiplication, we have to divide. Once again, what I do to the middle, I have to do to the left, and I have to do to the right. -15 divided by -3 is a +5. Notice I divided by a negative, so I have to flip both inequality signs. Less than becomes greater than. -3 divided by -3 is just a 1. Less than becomes greater than. 6 divided by -3 is a -2. So this is my solution. It just looks kind of different. You guys can rewrite this in a format that you're more familiar with by simply picking it apart. Now notice if you look at the front half of this compound inequality, you have x is less than 5. Notice that the inequality is pointed towards the x. When you go to write that with the variable on the left, because that's what most students like, that's what they're used to graphing, is with the variable on the left, make sure you write your variable on the left, but then make sure that inequality sign is pointed towards the variable. If the inequality sign was open towards the variable, you'd want to make sure it was open towards the variable down here as well. And then carry down your 5. I'm going to insert that word and, so I know that this is an intersection. I don't forget it. And then the second half of the inequality is pretty easy to carry down. It's already written in the format you're used to with the variable on the left. So now draw your number line, plot your values. -2 is going to get a closed circle because it has an equal sign, and 5 is going to get an open circle. X is greater than or equal to -2 is going to mean shade to the right. X less than 5 is going to mean shade to the left. Now remember, with intersections, only the part of the shading that overlaps is your solution, nothing else. So notice that these yellow lines are overlapping in between those circles that we drew. So that is where our solution is going to fall, is in between those values. Nothing outside of those circles is our solution, only that green area, because that is where the overlapped shading is. So I'm going to check my solution to make sure I did it correctly. I'm going to pick a number in that shaded region. I'll pick 0. You guys could pick another number as long as it falls in that shaded region. I'm going to replace x with 0. When I simplify that down, -3 times 0 is just 0. 0 plus 3 is 3. Once again, when you're in this format, you guys can break it apart, just like we did over here. So now you have your two statements, your two inequalities. Remember, for your intersections, your and statements, both statements have to be true for the entire compound inequality to be a true statement. That's a must. So let's go back up to our first inequality. Negative 13 is less than 3. Well, that's a true statement. And 3 is less than or equal to 9. That's a true statement as well. So I know my compound inequality is true. I've done everything correctly. If you would have checked your work and maybe this would not have been a true statement, that would have been your red flag that, hey, you did something wrong, you need to go back and check your work. Here are a couple problems for you to practice. I have the answers listed below. Take a second to pause the video and try to work these out on your own. If you have any questions or you're struggling, make sure you come and ask me for help. Next, we have our error analysis problem. Explain what is wrong in the following problem and how you knew there was an error. Well, if you look, this is the problem given. I know that's an intersection because of the formatting. It doesn't have that or word, so I know it's going to be an intersection. The problem starts off by adding 4 to the middle and to the left and to the right. They want to move the 4. The opposite of subtracting 4 is adding 4. It looks good to me. Negative 4 plus 4 is 0, so 2x. 10 plus 4 is 14. Negative 2 plus 4 is a positive 2. Next, I need to get x by itself. I have 2 times x, so to remove the multiplication, I have to divide. Well, the problem, they subtracted. So that is our error. That is why it does not work out. That's what was done wrong. So if you would have divided by 2 like you were supposed to, you should have gotten 1 on this side, x, and then 14 divided by 2 would have given you 7. So that is where they went wrong in this problem. Now, if you were going through and maybe you didn't catch that error, when you got to this section over here is where you definitely should have realized there is definitely something wrong with this problem. Because when you check your answers, remember, for an intersection, both statements have to be true for the entire compound inequality to be true. Well, our first statement is true, but the second one is not. So that is your red flag that, hey, there is something wrong with this problem. I need to go back and look at it. So always check your answer and be on the lookout for any mistakes that you may have made. Alright, last problem for you guys to try on your own. Take a second to try this problem out, and then we will discuss it. The first thing that you should do is distribute the half. Remember, whenever you're dealing with fractions, multiply to the top, divide the bottom. 4x times 1 is 4x. Divide by 2 is 2x. Negative 6 times 1 is negative 6. Divide by 2 is negative 3. Notice I bring down the inequality in the 7. Over here, 6 times negative 12 is negative 72. 6 times 3 is 18x. Bring down the inequality sign, bring down the negative 42. So I'm dealing with an OR statement. This is going to be a union. I just solved this as 2 separate inequalities, and I should get 2 inequalities as my answer. So first, over here, I need to move this negative 3, so I'm going to add 3 to both sides. Over here, I need to get x by itself, so I actually need to start by adding 72 to both sides. When I simplify down, I get 2x is greater than or equal to 10, or 18x is less than or equal to 30. Next, I need to get x by itself, so I'm going to divide by 2. And over here, I'm going to divide by 18. 10 divided by 2 gives me 5. 30 divided by 18, it does not divide evenly. However, instead of writing it as a decimal, using that calculator, just reduce the fraction. 30 over 18, if you divide the top and the bottom by 6, you should get 5/3. Remember to graph your solution on a number line to represent the solution set. 5/3 is smaller than 5, so it should be on the right of 5, or I'm sorry, the left of 5. Your inequality signs both have an equal sign, so you should have a closed circle. X is greater than 5 should be shaded to the right. X less than or equal to 5/3 should be shaded to the left. I'm going to check my solution by choosing 6. And I'm going to plug 6 in for x. When I simplify that down, I get 24 minus 6 and negative 12 plus 18. I get 18, a half times 18, and 6 times 6. 1/2 times 18 is 9, and 6 times 6 is 36. So here are my two statements. Remember, for a union, we're dealing with an OR statement, so only one of those statements has to be true for the entire inequality to be true. So 9 greater than or equal to 7. That's a true statement, and 36 less than or equal to 42 is a true statement as well. So it just so happened for that problem, both statements were true, which is fine. As long as one of them is true, the entire inequality is true. So did you meet the objective? Now is your chance to prove it. You should be able to solve a compound inequality at this point. I have two problems I want you guys to try out. They are multiple choice, so solve the problem. These are the answers that you should get. If you're still struggling with material, please make sure you come in and see me for additional help.